Hello students. So in this video we will study data operations with Numpy. Okay. Numpy is one of the important library which we will use in uh, data manipulation. Okay, and data operations. So pandas we already covered. So now it's time for Numpy. Okay. So in this introduction we will see introduction to Numpy, then how to install and import libraries. Then we will do a speed check. Okay, we will see that numpy is very faster than a list. Then we will create numpy, we will be creating numpy arrays by different manners, then checking the array attributes. Then we will check the different attributes of array. Okay, then we will do array initialization, that there are some functions by which we can do array initialization. After that, array initialization using random numbers. So there are two ways, we will see that also. Then numpy indexing, then slicing and conditional array indexing. Okay, this thing we see. Then numpy broadcasting, numpy mathematical functions. After that, array manipulation, shape manipulation, and array merging and splitting. Okay, uh, dot concat dot b split dot h split are there. Okay, and then we will conclude our video. So let's start with the introduction to NumPy. NumPy is a library developed for Python which can handle large and multi-dimensional arrays and matrices. Okay, so this is the library which is developed for Python which can handle large multi-dimensional arrays and matrices. Okay, it has a large collection of mathematical functions to operate on these arrays. Okay, so it have large collection of mathematical functions to operate on these arrays. Okay, so it is remarkably faster than Python list for many reasons. So it is quite faster than Python list. Okay, so what are the reasons? It was designed for efficient data storage. So it was designed for efficient data storage. All the elements of NumPy arrays are stored sequentially. So here all elements are stored sequentially with a fixed width for each value. Okay, and fixed width is there for each value. On the other hand, lists are pointers to data stored elsewhere. Or what happen in list are pointers to data stored elsewhere. The number of separate reads the number of separate reads computer has to do is smaller for NumPy. Okay, so due to why the number of separate reads the computer had to do is smaller for NumPy. NumPy has uniform data types instead of list. In list we have different types of data types, but NumPy has uniform data type only. Okay, the computer perform a logic for each different element type. Okay, computer performs a logic for each different data type. Due to this reason, NumPy completely avoids the extra computation. So due to this, as data is stored sequentially, also uniform data types are there. So NumPy completely avoids extra computation. NumPy has optimized functions for many mathematical operations on array and matrices. Okay, this is the reason they are faster than regular math operations on list. Okay, installing and importing libraries. So import NumPy as np. Okay, and then we will import time. So here we have imported NumPy as np. Np is alias we given to like nickname to NumPy. Uh, okay, then we import time package. Okay, so first of all, guys, we will do a speed check. In this section, we will perform a speed comparison between Python list and NumPy. Okay, so what we will do, we will make two functions. In those, we will prepare Python list. Then we will array NumPy array. Okay, then we add both list or both arrays and see what is the difference in time. Okay, So import numpy as np, okay, and then import time, then def pure python version. Then we will pass argument. What it will do, first of all it will calculate time, okay. Time python equal to time dot time, then my list 1 equal to range, and then we need to define size of vector also, guys. Size of vector range, and then we will give this value, okay, and then my list 2 equal to range, or you can say size of vector. Now sum list equal to my list 1 plus my list 2, okay, and then okay, for I in range length of my list 1, okay, and then return time dot time minus time underscore python, okay, and at the same time we will define numpy version. It will take argument, then time for numpy equal to time dot time, and then what will do, my array 1 equal to np dot array, and then sorry mp dot a range, a range size of vector, okay, and then my arr2 is equal to np dot a range size of vector, and then sum array is equal to my array 1 plus my array 2, okay, return time minus time underscore numpy. Okay. So now we will calculate Python time equal to pure Python version. Okay. And numpy time equal to numpy version. Okay. And Python time divided by numpy time. Okay. Print Python time divided by numpy time. So let's run this and see what happen. Oh great, we get some. Okay. So here, which elements you want to add? This you need to mention. Hope it will work now. Okay. So for my list I minus 2 for I in range length of my list. So it is 73 times faster than. So you can see guys. Okay. So NumPy is faster than Python. Okay. We observe that NumPy is way more faster than Python list. Also, it's more convenient when lending large data sets at one. Okay. Now we will see creating NumPy arrays. The key feature of NumPy is its n-dimensional array or ND array. Okay. Uh, Having the below specialties. It is faster and flexible containers for large datasets in Python. These arrays enable you to carry mathematical operations on whole block of data. It is a generic multi-dimensional container for data. It is a generic multi-dimensional container where each container is of same type. Okay. Below we will see some example of ND array showing 1D, 2D and 3D array. Okay, so type, if we want to see type of what, np dot array. Okay, and we are passing list 1 2 3. Okay, so it will come nd array. Okay, now we are defining two functions. First is math 45 comma 88 comma 76, then English 55 comma 90 comma 82. Okay, and then we do math plus English. So like it will add to list. Okay, but if we do same thing with arrays. Okay, so math array equal to np dot array and then math, then English array equal to np dot array English. Okay, and then we do math array plus English array. So it will do element wise element by element operation. Okay, now creating Python list. So what we are doing here, we are creating my list, that is 1 2 3 4 5. Then display the type of my list variable, then we are displaying the type. Okay, then we are printing my list, creating one dimensional array using my list. So this is the my list 1 2 3 4 5. Then we are creating numpy array, type superman equal to np dot array, and then my list. Okay, print type of superman. So superman is n dimensional array. Okay, and if you try to write superman, so it is array. Okay, now we are creating a list of list. Okay, so what we are doing, we are creating score equal to 1 2 3, then 5 6 7. Okay, so this is the list of list, then score 0, then again 0, so it will give 1. So okay, so for two dimension we will do like this. So if we convert it, np dot array, okay, score, it will create two dimensional array. Okay, so this is the thing. So we can create like this also, it will create three dimensional array. Okay, creating a Python list containing sub list of values, and then it will be two dimensional array. So this is the thing, numpy arrays have the same functionalities as Python list, but the difference lies in their functionality and speed of doing operations. So this is the main difference. The important difference in working with numpy arrays is i- it's more convenient and fast. Okay, and the array is widely used for handling images as huge matrix of numbers. Okay, and it's easier and faster to do any image operation in numpy arrays as compared to Python list. So this is the thing. Checking the array attributes. Now, if we want to check the array attributes, dot shape, dot endim, and dot dtype. Okay, so these are the three attributes we can check. Okay, so here are some numpy functions to know more attributes. We can use dot shape. It gives the information about the dimensions of an ND array. Okay, rows and columns. Then dot endim. It gives how much dimensional array it is, 1D, 2D, 3D. Okay. Then we have dot d type. It gives the type of layout or data being stored. Okay. So score array equal to np dot array, then score. Okay, score dot end, so it is two dimensional. Okay, then score dot shape, so 2 into 3 it should be. Okay, then score array dot d type, so it is int 64. Okay, so these are the things you need to, sorry, int 32. So display the type of array variable. Okay, so type of array variable um, will be whatever it should be, no issue. Okay, so these are the thing, shape and dim and d type. Okay, so now we have seen how easy it is to make use of shape and dim and d type. Okay, functions to check the shape, dimensions and d types of the data. While doing EDA, these things help us. Okay, or pre-processing, these things help us. Now array initialization. So in this session we will learn some array initialization methods. Okay, we will see some array initialization. So there are five methods: dot arrays, dot zeros, dot ones, dot linspace and dot i's. Okay, so what are these? Dot arrange, dot zeros, np dot zeros, np dot ones. Okay, np dot linspace, and in last np dot I. So these are the so arrange do what it do, dot arrange creates an array of specified range. Okay, or you can say step size and type of data to be stored. So dot arrange generates an array of specified range. Arrange generates an array of specified range, step size and type of data to be stored. Okay, zeros generate an array containing zero values. Then ones generate an array containing ones as values. Then linspace generate and evenly spaced numbers over a specified interval. Then generates a 2D array with ones on the diagonal and zeros elsewhere. So this is the thing. Okay, so now np dot arrange. First of all, see arrange, np dot arrange, and how much should be the range? 3 to 20. Okay, start and step size will be there, so it will go like this. So 17 should be the length. Okay, let's see. Okay, now we can do np dot arrange, same 3 to 20 with the step size of 2. Okay, so if we want to see the length of this, so it will be 9. Okay, so this is the thing. If we want to keep track of expenses, so uh, head count cost of all employees. Okay, so we can do like there are 50 employees, then np dot zeros. Okay, and then we can mention 50. So this is the array for all employees. Okay, 0 0 0. This is the array initialization. Now stock market. uh, so we can start with np dot ones. Okay, np dot ones. In np dot ones, let make 3. Okay, dot d type. So this is the thing. Okay, with the help of np dot ones we can do. Now we will do np dot len space. Okay, so np dot len space. In len space we need to define between 0 and 200, and how many values we want? 5. So like this we need to do. So now this is the identity matrix. Okay, so np dot I, and then in identity matrix I will mention 3. N or m we need to define. Data type also we need to define. Okay, so 3 if I will define, so 3 rows and 3 columns. Okay, generating an array of size 10 with a step size of 1. So this also we have seen. D type also we need to mention. So for example, if I will try to check D type here, dot D type, so it is int 32. If we mention none, then it means it int 32. Okay, so this also we have seen np dot zeros. So np dot zeros, then shape we need to define and D type we need to define. Okay, then np dot ones. So if we are doing np dot ones, then we need to define shape. Okay, and D type and order. Shape equal to 3 comma 3. Like this we can do. And np dot len space. Okay, np dot len space, and then we will do start, stop, and numbers. How much number should be there? Endpoint, and D type, axis, all these things we can mention in len space. Okay, so this is the thing. Okay, now np dot i's, we can mention n and m, number of rows and number of columns. So like this we can do. Now we will see random array initialization. Okay, this is the another thing, random array initialization. So in this section we are going to see how to populate array with random numbers. Okay, how we can populate array with random numbers. We will get to know about the following two functions of numpy. Okay, so we will get to know about the following two function of numpy. First one is dot random dot rand. Okay, dot random dot rand n. Okay, so these are the two functions, dot random dot rand, dot random dot rand n. Okay, so dot random dot rand, what it do? It creates an array of the given shape. Okay, so what it do? It creates an array of the given shape and populate it with random samples. Okay, for a uniform distribution over 0 and 1. So it will create array of given shape, whatever shape we tell him to create, and it will populate it with the random sample from a uniform distribution from 0 and 1. So plot will be like, it will be uniform distribution. Okay. And dot random dot rand, and what it will do, it will return a sample or samples from a standard normal distribution with mean 0 and variance 1. Okay, so it will give like bell curve. Okay, so import pandas as pd. Import pandas as pd, then pd dot series. Okay, pd dot series, np dot random dot rand, and then 1 1 2 3 4 5. Okay, and then dot plot dot hist. Okay, so it will do like this. Okay, then np dot random dot rand n. Okay, and then so pd dot series dot plot dot hist. So it will give like this. Okay, like a bell curve. It is like a bell curve. So this is the thing. Okay, generates an array of 5 random values. So these will be any random values. Okay, so these are the things we have seen. Okay, uh, we can do like generates an array of value uh, like rand n and random, generates an array of 6 random values dot rand 6, display array containing random values, display the resolution, reshape to it. Okay, so in various applications like assigning weights in artificial neural networks, arrays need to be initialized randomly. For this purpose, there are various predefined functions in NumPy, and we have just seen how to make use of reshape and rand function. Okay, so this all we have covered. Okay, a range dot zeros dot ones dot linspace dot I, then dot random dot rand n, like this. Okay, now come guys, NumPy indexing. In this section we will show how NumPy based elements are indexed and how to access these elements. Okay, in this section we will show how NumPy based elements are indexed and how to access. So index means position of the value. Okay, what is the position of the value, and it is sequential from 0 to n minus 1. Okay, then array square bracket index, like this we have to do. So creating an array of 10 values having from 0 to 1. So my array equal to np dot a range from 0 to 11 with a step size of 1. Okay, then print my array, and then print uh, my array at index 1, so it will be there. Okay, we just saw how that we can access individual elements of an array by calling them by their indices. Okay, now let's see array slicing. To access more than one element of an array, use slicing elements. Okay, if if we want to access one element, then we can use indexing. Okay, and if you want to use more than one element, then we can use slicing. So array equal to np dot a range, then 5 to 21. So this is the range. Okay, so its length should be 16, I think so. Yes. Okay, so array, mm, so what we want, indexing start from 2 and goes till 10 with a step size of 2. So 2, 4, 6, 8 and 10. But the end is not inclusive in this, so 10 will be left. Okay, 2, 4, 6, 8. Okay, like this. Okay, now we will see this cust. Okay, so for cust we have defined this. Cust equal to np dot a range, sorry, array, and then cust new equal to cust plus 1. Cust new equal to this. So like this we can do. Okay, then cust new is greater than 15. Greater than 15. So it will give like this. Okay, so if we want to print all elements which are not greater than 15, then cast new, then square bracket and use tilde sign, and then cast new greater than 15, enter. So it will give all elements which are not greater than 15. Okay, like this we can do. So if np dot array, okay, so np dot a range from it, creating array of 10 values from 0 to 11. So this is the array. Now we want to access, so now accessing elements ranging from index 1 to 5. Okay, so if we want to access 1 to 5, okay, so till 4 it should come. Okay, the first element that is in extracted is of index 1 and last element is of index 4. Okay, this is the thing we need to take care here. Now accessing elements ranging from index 8 onwards. Okay, so if we want to index from 8 onwards, then we can write like this: my array square bracket 8, then a colon and blank. Okay, accessing elements ranging till index 6. Okay, so semicolon 6. Numpy arrays are mutable. It implies that you can change the value of the array. Okay, so if like my array is like this, okay, and we want to change from 0 to 5 with value minus 5, and then print my array, so it will appear like this. You can also perform slicing operations on 2D array. So on 2D array also we can do slicing operation. For example, let's suppose this is the 2D array, and let's see how it's look like. So it will be like 2D array. Okay, so what they are doing, accessing elements present. Okay, 1 minute, we will do these three as task, no issue. Okay, so guys, see, accessing element present at 0th row and second column. So array 2D, we want to do it 0th row and second column, so it will give 1, sorry, 0 1 2, it will give 2. Accessing elements from row first to uh, array underscore 2D, accessing elements from rows first to second, comma column first to second, it will give 4. Okay. So now accessing element from row till second and column from first onwards. So array 2D, rows till second, comma first onward. So it will come like this. Okay, so hope. So through these examples we have seen that we can access one or multiple elements of an array using slicing. At the time when we need, we can extract sub arrays from arrays. Okay, so this is okay for this video. From next we will continue with conditional array indexing. Okay, thank you guys.